Hey guys, this is Dr. Callahan with week 15, Wednesday for Probstats. How are you guys doing? Go ahead and pause the video and answer the following questions. All right, so today you guys have two pages that are going to go over with Hamilton circuits and paths and also with the formulas. So the two different worksheets that you guys should have looks like this. Here's the first page. And then here's a second page. However, if you're not home, you're welcome to just kind of follow along with this and then just show your work on a separate piece of paper, take a photo of it, and then upload it to MS Teams. All right, let's go ahead and take a look at this. So let's go ahead and take a look at this. So a Hamilton's path is basically a path that visits each vertex once and only once. So if you think about path, vertex is the point. So for example, if you take a look at this one here, you're going from point A to point B, from point B to point C, from point C, let's see if we can go to point D, from point D to point A. We can't do that because then it basically revisits it twice with the A. So I have to stop right there. How about from C to E, E to F, F to G, G to A? See, can't really do it because it goes back to it one more time. So unfortunately with the first question right here, you do not have a Hamilton path, so it just does not work. A Hamilton circuit means that it visits each vertex once and only once. So for example, this one, you go this way, second vertex, third vertex, fourth vertex, and there's no way for you to actually make that work. Similar to this question here, from here to here, 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 and there's just no way for you to get around it. I mean, if you try once more from this to here, 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 but then you still have this piece right there. So Euler's path are basically involving with edges. Hamilton's path and circuits are with vertices. So make sure you fill out a blank. Let's complete the graph. Complete the graph means a graph with n vertices in which every pair of vertices is joined by an edge. The number of edges is always represented by the letter K sub n. This has the formula for the number of edges. So as long as you know how many edges you have, you just simply put the number of edges in n times n minus 1 divided by 2, and that will give you the number of edges with that vertex. Now, to find the number of Hamilton circuits, the formula is similar. So for example, if I take a look over here, it is going to be n minus 1 factorial. So let's say, for example, we have 6 vertices. If I have 6 vertices, how many edges would I have then? Well, if I plug this in here, I will have this formula as 6 times 6 minus 1 is 5 over 2. 6 times 5 is 30. Half of 30 is 15. And so you will have 15 edges. Now, similarly, if I were to find the Hamilton circuit, I would do 6 minus 1, which is 5, and then 5 factorial is 5 times 4 times 3 times 2 times 1, which is going to give me 20 times 6, which is 120 different circuits. The traveling salesman problem involves weighted graphs. Weighted graphs are any graphs whose edges have a number that's attached to them. Like if you're traveling from Reno to San Francisco to Phoenix to Austin, Texas, Austin to New York, and then back to Reno. There's probably different ways for you to go about your trip. You could probably go to Austin first, and the goal of this is to find the trip with the least expensive route, but making it back home to Reno. The weights are the numbers of each edges that represents a variable, like the cost of your trip with the airplane, time, distance, and the total weight is basically just add up all the edges in the circuit. All right, so for some example, that how we use Hamilton circuit is like routing school buses, package delivery with Amazon, circuit boards, scheduling job on a computer, running errands around town. So some of the strategies the first one anyways, and this is an exhaustive one, is to calculate every possible circuit and choose the one with the smallest total weight, which is very time consuming because you literally have to find all the different type of Hamilton circuits from one point to the next, and you have to add everything together. Now, the second strategy is a little bit easier. So from home, go to the cheapest vertex and continue this until you reach every vertex, and then you basically go back home. So this is probably just one route, and most likely it's going to be the cheapest. So for example, let's go ahead and find the Hamilton path that starts with A and end with E. So pause the video and see if you're able to find it from this diagram. One possibility is AFB. So from A you go to F, from F you go to B you go down to C to G, G to D, and then D to E. Now, second part is find a Hamilton path that starts with A, and I would like you to go ahead and end at C. So pause the video and find that one. The one that I did was from A to F, F to B down to E to D, D to G, and then end at C. Optimal algorithm is an algorithm that produces the optimal or best solution. Inefficient algorithm is time consuming and not practical. So in this situation, might be like the most expensive route. Efficient algorithm is going to be the process that is the most reasonable, and relative error is going to be simply measuring of how far off you are from the optimal solution. So your relative error is the weight minus the optimal divided by the optimum. Approximate algorithm is an algorithm that produces a solution close to the optimal solution. Here are 3 steps for the brute force algorithm. The first step is going to be make a list of every possible Hamilton circuit, which is going to be, long and extensive. Second step, find the total weight of each circuit. And 3, choose a circuit with the smallest weight. The nearest neighbor algorithm is approximate but efficient, and you start with a designated vertex. The first step involves going from there to the nearest neighbor or the cheapest or shortest route. The middle step is from each new vertex, go to the nearest neighbor without revisiting a vertex. And the last step is once all the vertex have been visited, then you simply just go home. So let's take a look at example 2. So you have all these different routes. I want you to find the nearest neighbor circuit that starts with vertex A, which is right here. What is the cost of this trip? So following these 3 steps, let's see if we're able to do that. So from here, let's go ahead and find the cheapest or the least expensive, cheapest or shortest. So from here, we can either go to A to C, which is from here to here, to E to D. And then to B, from D to B, and then from B back to A. Calculating the entire trip itself, if you look at it, you're going from A to C, which is the cheapest trip, or with the cheapest route, which is going to be $119. So that one is the cheapest. And then from that, I'm going to go from C over to E, which is only 120, so still fairly cheap. And then from E, I'm going to go to the shortest route, which is the D. And then from D, I'm going to go over to B, which is also a cheaper trip. And then from that, you're going to go down to back to A. And altogether, your total trip, you just simply add them together. All right, so now that we went ahead and practiced with that, I have this part here, which is 4 questions that I would like you guys to go ahead and find the answer to. So for questions like number 3, how many edges are there? If n equals 20, remember you're going to use n times n minus 1 divided by 2, which is the number of edges. And then questions 5, A, and B, I want you guys to go ahead and find the nearest neighbor circuit, Nashville, starting with the vertex itself. All right, you guys. Then after that, I have one more thing for you guys to work on, which is a quizzes. So you are going to do the Hamilton circuit, which is going to be 15 questions. I'm going to go ahead and assign it to you guys separately, so you have a few days to complete it. And then you just need to go to joinmyquiz.com, enter code 09242378. All right, you guys, I hope you have a wonderful week. As always, stay safe and healthy. Take care.